How can this be possible? Imagine yourself descending into the deep ocean, a world of perpetual twilight. The light from the surface has long since vanished, replaced by the focused beams of your submersible. Outside, the pressure is immense, a crushing weight in a realm few have ever seen. You are suspended in the cool, blue water, surrounded by the gentle quiet of the abyss. The only sounds are the soft hum of your vehicle and the occasional click of unseen creatures. Particles of marine snow drift past your viewport, a silent, constant blizzard. As you swim downward, a strange sight appears below you. At first, it's just a shimmer in the water, a visual distortion like heat haze that has no place in the cold, stable, deep. It resolves into a clear, defined line cutting across the seafloor. On one side, the water is the familiar blue of the ocean. On the other, it seems different, darker, and strangely still. As you get closer, you see it's a lake nestled at the bottom of the sea. Its surface is a perfect dark mirror, reflecting your lights with glassy clarity. While the surrounding ocean has a gentle current, the water in this basin is utterly motionless, a pocket of impossible stillness. A distinct edge separates this mysterious water from the ocean around it. A lone fish approaches, pauses, as if meeting a wall, and turns away. It senses a profound chemical difference, a toxic frontier it dares not cross. This is a place where the normal rules of the ocean seem to bend and break. What you are witnessing is a brine pool, a phenomenon that has perplexed oceanographers for decades, presenting a stunning visual paradox. For years it has puzzled observers and provoked one question: how can there be a lake under the sea? Its surface is eerily calm, like dark glass, broken only by slow bubbles of methane gas seeping from below. They rise through the dense brine, but as they hit the boundary, the halocline, they seem to dissolve, crossing from one chemical reality to another. It feels like something from a storybook, a portal to another dimension. Images of these pools captivate scientists and viewers alike, reminding us our planet still hides profound mysteries. Our intuition says, water mixes with water, yet here is a body of liquid that refuses to mix, maintaining its shape and boundaries. The question is not just how this is possible, but why. These incredible, otherworldly features are entirely real, and they have names. To scientists, they are known as brine pools. A brine pool is essentially an underwater lake, a depression in the seafloor filled with water that is dramatically saltier, sometimes 3 to 8 times more so, than the surrounding ocean. This extreme salinity makes the water incredibly dense, causing it to settle and resist mixing with the less dense seawater above. One of the most famous examples lies deep in the Gulf of Mexico, nicknamed the Jacuzzi of Despair. Its water is not only 4 times saltier than the ocean but also a warm 19 degrees Celsius, a stark contrast to the frigid 4-degree water surrounding it. Robotic explorers and manned submersibles visit this site, mapping its strange boundaries. The footage they send back reveals a placid, mirror-like surface. Its shoreline is a macabre museum, littered with the perfectly preserved remains of unfortunate creatures. The anoxic, hypersaline water acts as a pickling agent, halting decomposition, creating a stark division between two worlds, the vibrant ocean above and the silent pool of death below. Another spectacle appears off Mauritius, where an optical illusion suggests an entire waterfall cascading into a dark abyss, a powerful visual reminder of how density can trick the eye. Behind the apparent magic is the simple science of density. The secret ingredient, quite simply, is salt. We intuitively expect water to mix with water, so a distinct pool with a razor-sharp edge feels fundamentally wrong. This boundary, called a halocline, is so abrupt that marine life reacts instantly. Fish and crabs swim right to the edge, then stop, baffled. Their bodies cannot handle such a sudden, extreme change in salinity. For any creature unlucky enough to fall in, the experience is one of immediate toxic shock. The brine is often completely devoid of oxygen and saturated with dissolved methane and hydrogen sulfide. This lethal cocktail is instantly fatal to most complex life, turning the shoreline into a graveyard. The Gulf of Mexico isn't the only place to find these deep-sea oddities. The Red Sea is home to more than 24 brine pools, some of the hottest and saltiest on Earth. Heated by geothermal activity, these pools can reach temperatures over 70 degrees Celsius and are rich in heavy metals, painting the seafloor in alien hues. The fact that these two bodies of water can lie in contact for years without mixing creates a powerful illusion of a physics-defying lake. It's a captivating natural spectacle that seems to break all the rules, and it demands a deeper explanation. The explanation is straightforward: density. The water in a brine pool is so saturated with salt that it becomes significantly heavier, or denser, than the surrounding seawater. Pulled down by gravity, this dense brine sinks, flowing across the ocean floor until it settles in a basin, forming a distinct, contained lake. The less dense seawater naturally floats on top, unable to displace the heavy brine. This stable layering is called stratification. It's like pouring honey into water. The denser liquid sinks and forms its own layer at the bottom, resisting mixing. But why don't ocean currents stir them together? The deep ocean's flow is often slow and smooth, lacking the chaotic energy, the turbulence, needed to overcome this strong density barrier. The currents simply glide over the top. This sharp boundary is called a halocline. It can be just inches thick, yet it acts as a formidable physical wall between two worlds. Across this thin veil, salinity and temperature change abruptly. The brine below is also often anoxic, devoid of oxygen, and laced with toxic chemicals, making it a lethal trap for most marine life. So where does all this salt come from? It originates from massive, ancient salt deposits buried deep beneath the seafloor. These salt domes push up through layers of sediment over millions of years in a process called salt tectonics. Seawater percolates down through cracks in the crust, dissolves these ancient salt layers, and becomes supersaturated. This brine then makes its way back to the seafloor, emerging through fissures and vents. As it emerges into the cold deep, its extreme density takes over. It spills out not as a rising plume, but as a heavy river that flows downhill along the seabed, eventually collecting in basins. The result is this surreal underwater lake. It may look like magic, but it is fundamental physics on full, elegant display. Year after year, the edge holds firm. No physical laws are broken, they are simply obeyed with perfect precision. The famous underwater waterfall of Mauritius, however, is a different kind of wonder, a masterful optical illusion. Here, it's not dense water, but a cascade of sand and silt being pulled by currents off a steep coastal shelf into the dark abyss. The sharp edge is the brink of the shelf, and the flowing patterns of pale sediment against the deep blue water fool the eye into seeing a massive, plunging waterfall. In both cases, whether a real lake of brine or an illusion of sand, what we see is a stunning interplay of perspective, geology, and the unwavering laws of physics. Now, step inside a submersible approaching a brine pool for the first time. Through thick acrylic, a dark circle materializes out of the gloom. Lights sweep across stark white mussel shells lining the perimeter. A probe dips into the brine. Salinity spikes, temperature drops, gases register on the console. The boundary shimmers, a halocline, like a silvery ceiling between worlds. As the craft dips in, buoyancy shifts dramatically. Ballast must be trimmed to hold position. The lights cut through murky brine to barren black sediment and preserved husks, lethal water, frozen time, samples collected, cores retrieved, every observation logged. This is a natural laboratory. While the interior is deadly, the edges teem with life. Mussels and tube worms thrive in a ring of abundance. Chemicals that make the brine toxic power chemosynthesis. Microbes consume sulfide and methane, fueling the food web. Bacteria live in mussel gills. Tube worms wave red plumes as they harvest chemicals from the water. If life thrives here, in dark, cold, high-pressure, toxic waters, icy moons with chemical energy may host it too. A brine pool is an island, a separate kingdom revealing life's tenacity. Returning to Mauritius. From the air, a perpetual waterfall, actually sand and silt flowing off a steep shelf. Drop-off, flowing patterns, and color gradients cue our brains to see falling water. Nature is full of deceptions, from animal camouflage to atmospheric mirages. Brine pools are invaluable laboratories, helping us understand how heat, salt, and nutrients move through the deep sea. This knowledge feeds into models of global circulation that regulate Earth's climate. Chemosynthesis rewrote biology. These edges show how life can flourish without sunlight, vital for astrobiology. Anoxic, salty brines preserve sediments like archives, capturing climate shifts, sea level changes, even undersea slides. Look at a brine pool and think density. Picture the shimmering halocline, the invisible wall between two worlds. Ask, what is it made of? What makes it heavy or light? How does it move? Basic principles hold the answers. Salt, density, slope, and relentless currents are the artists behind these masterpieces. These places do not break nature's rules. They reveal them in the most astonishing ways. An underwater lake, a real, tangible wonder, alien as any world among the stars.